So number one, we're going to determine the number of total zeros. So total zeros is easy. Total zeros is always equal to your highest exponent. The highest exponent, we have a 3, we have a 2, we have a 1. So the highest exponent is 3. That is the degree. So because the highest exponent is 3, the degree is 3. So that means we have 3 total zeros. Okay, let's go ahead and do that on the other two. How many total zeros here? I would say, well, there's a 5, 4, 3, 2, 1. So I would say total zeros is 5, because that is the highest exponent. It's not always the first term. Be careful. Here, total zeros, and I should make that plural. Total zeros would be 3. Okay. So now we have total zeros. That's the easy part. Now let's go through and determine the number of real zeros. And the number of non-real zeros. And we're going to do that for both. Okay. The thing to remember is that what these two boxes should add up to 3. These two boxes should add up to 5. These two boxes should also add up to 3. Another thing to remember is non-real zeros. These always come in evens. So the number here has to be either 0, 2, 4, 6, 8, and so on. You cannot have one complex. You cannot have 3 complex. It has to be an even. So how do you know how many are real and how many are non-real? I would just type this into Desmos. So x cubed minus 5x squared plus x minus 5. Let's see what the graph looks like. We're looking for 3 total because it's to the 3rd power. Notice it only crosses once, and it's not a bounce, it's not a squiggle, and if I zoom way out I can see that all it does is come up and only has one solution. Students the other day were calling this a solution. That's not a solution, that's a relative maximum. We're looking for where it crosses the x-axis. So I would say one real solution, so then the other 2 must be non-real. So I would say 1 and 2. And then I could even probably put that in there. See? So now we have this quintic to the 5th power. That's what we call 5th power polynomials. And what we're going to do is we're going to type this into Desmos, and we're going to look. And here's what I get. And I zoom way out, and I see that these are the only solutions. I have one here, and I have one here. This one counts twice, though, because it's a bounce. Remember, bounces count twice. So I got 2 here, 1 here. That makes 3 real, which would then make 2 non-real. So I would say 3 and 2, and then if I wanted proof for the person, I could just go here, screenshot it. There we go. All right, next we're looking for 3 total zeros. And keep in mind, the answer is either going to be 3 and 0 or 1 and 2. Those are the only options. So if I go look at the graph, I see that it has one real solution. One real, that means the other two are complex. So I put 1 and 2. And then if I wanted to, I could take a little screenshot there, add it to my picture. And there we go.